Hello everyone, today I will be talking about pump slip or the phenomenon that's called slippage. Slippage is the loss of pumping capacity due to fluid leaking back through a pump from the discharge side to the intake side, and of course it will affect the pump efficiency. Now let's focus on progressive cavity pump. Here is the curve of the flow rate against the delta P. We see from the curve that Q is constant till a critical delta P. After that, with the progressive delta P, we can see the flow rate decreases with increasing the differential pressure across the pump. This phenomena is called the slippage, and because of this, we can see different flow capacity or change of the pump efficiency. Here is the pressure development inside the pump. We see that from intake to discharge of the pump, if there is no slippage, so the discharge pressures represents only the delta P that happens across the pump without any slippage. If there is a slippage across the pump, then the discharge pressure should have a considerable amount of slippage across the pump. That's why we see inefficiency in the pump, and this amount should be considered during design, and because it has a foreseen impact on the pump efficiency with time. Now let's define the slippage again, as it is the difference between the flow rate at 0 delta P, which is the theoretical flow rate, and the actual flow rate at operating delta P. For a given pump fluid and temperature, this slippage is only a function of delta P regardless of the RPM that the pump running with. So the volumetric efficiency, it is the ratio of the actual flow rate at this specified delta P and the theoretical flow rate that happens without any effect of delta P or at 0 delta P. We see that if the theoretical flow rate at 0 delta P is QO, then at delta P above the critical delta P, there will be a different flow rate or difference in the flow rate. So the actual flow rate of the pump will be Q1. So the volumetric efficiency will be eta 1, which is the division of Q1 by QO. This is for a specific RPM. Now let's see the effect if we choose another RPM, what will happen. So we has defined the slip as a dependent factor on delta P only, and if the RPM increases, the theoretical flow rate will increase because it's only affected by, or it can be affected of course by the RPM that's running, and of course it is proportional because QO increases with increasing the RPM. Now as we define the slip as constant amount at delta P, so accordingly the eta or the efficiency of the pump will be more or greater at higher RPM. So now let's conclude that the efficiency of any pump increases with increasing the RPM because the slip is only dependent on delta P regardless of the speed of the pump. This is all for now. Thank you, and let's meet on another video. Bye bye.